Okay, I'm going to go over problem 76 from chapter 3. And in this problem, the range of a projectile, which would be r, is equal to the maximum height, which I'll label as h. So I could say that r is equal to h. And I am actually trying to figure out what this theta is. And actually in problem 76, theta naught, the initial velocity, v naught, is known. Well, I'm not really sure where to start. Why don't I just start plugging in, take on the y direction. In the y direction, I have y is equal to y naught, which I'll say is 0. And actually what I'm really trying to do is I'm trying to evaluate this so that when I'm at the maximum height, my range is 1/2. So this distance right here is in this overall range, but it would be r over 2 or h over 2. So here at this maximum height, I'm going to say that this y is then equal to h, and then my initial position would be 0 plus v naught y, which would be v naught sine theta t minus my 1/2 g, which is a t squared. Now let's look at the x direction. And in the x direction, I am going to be figuring out, all right, so at that time, total time divided by 2, which would be half. So it's the same time here, so it's the time to the maximum height is what I'm dealing with for this t. Or I could look at the total time, and this would be t over 2. It doesn't really matter. And so I end up with this x, which really is going to be, this x isn't the overall range, it's half of the range, or I could say that the half of the range is equal to that h over 2 because r is equal to h. So h over 2 is then equal to, let's say, x is equal to x naught is 0, plus v naught x, which will be v naught cosine theta t plus 1/2 at squared. I have no acceleration in the x direction. So look, I have an h here, I will actually sum these or set them equal to each other. So I have v naught sine theta t minus 1/2 gt squared is then equal to, I'll pull the 2 over here, 2 v naught cosine theta t. And look, I can cancel out a t from each term, but I'm still left with this t. So let me rearrange this. So I have v naught sine theta minus 2 v naught cosine theta is then equal to g over 2 t. So now I have 2 unknowns. So I'm going to have to look somewhere else. So I'll pick on the y just because I know that the velocity in the y direction starts with initial velocity, and at the maximum height it goes to 0. So remember, this time, this t in every single one of these equations is the t to the maximum height, the time to the maximum height. So I'll look at the velocity. I have v y is equal to v naught y plus at. There's my equation of constant acceleration. Well, I'm saying that this goes to 0. So then I end up, in this case, this is g is negative g. So I'll pull this over and I will set these, I'll set my initial velocity sine theta in the y direction is then equal to gt. All right, well, let's solve this for t and get rid of this t over here. So t is then equal to v naught sine theta over g. All right, so let's write this out further. I end up with v naught sine theta minus 2 v naught cosine theta is equal to g over 2. Now I'm plugging in t over here. So I end up with v naught sine theta over g. I'm canceling out my g, so there's not a g in any term. So I could be on the moon or I could be on Earth, doesn't matter. I'm canceling out all my initial velocities. So it doesn't matter what the initial velocity is. As long as I know what this angle is, no matter how fast I launch it, that height will equal my range. All right, so now I have a sine theta minus 2 cosine theta is equal to sine theta over 2. I'm going to pull the sine over here and the cosine over here, so maybe we can just see what's going on here. sine theta minus sine theta over 2 is then equal to 2 cosine theta. Oh, well, something minus a half is going to be half of that something. So we end up with sine theta over 2 is then equal to 2 cosine theta. I'll pull my cosine over here. I'll pull this 2 over here. So I end up with sine theta over cosine theta, which is equal to tan theta. And then I have this 2 that I pulled over, and that's going to be equal to 4. So therefore, theta is equal inverse tan of 4. Done.